everyone. So we are continuing to solve our CBSE 10th grade math board papers, and we are continuing with the question papers for 2019, and this is for the series JMS/1, and the code number is 30/1/2. So this is the second set for the paper 30/1, and we have already solved section A and section B in our previous video. So let's move to section C in this video, and it has 10 questions of 3 marks each. So 13th question, in this we are given a frequency distribution table and whose arithmetic mean is 53, and there is a missing frequency marked with K, and we have to find the value of K. In this question we are given a frequency distribution table. So we are given the class intervals and we are given the frequencies. Class intervals 0 to 20, 20 to 40, 40 to 60, then 60 to 80 and 80 to 100. And we are given the frequencies as 12, 15, 32, and we have a missing frequency as K here, and we are given this as 13. We are given mean is 53. To find K, we can use the assumed mean method. First, let's find out the X. So mid values of class intervals. So this will be 10, this will be 30, this will be 50, this will be 70 and 90 here. We can assume the mean as 50. We can find out the deviations from the assumed mean. So this would be X minus A. So here this would be minus 40, then minus 20. This would be 0, then 20 and 40. Now let's find out the values for frequency into deviations. Minus 480, and this would be minus 300. This would be 0, and this would be 20K, and this would be 520. Now here we have sum of frequencies as 72 plus K, and here we can find out sum of frequency into deviation values. So this would be 20K, 480 plus 300 is 780, 780 minus 520, so minus 260. We can find out the median by the formula assumed mean plus sum of FD values and sum of frequencies. And we are given the mean as 53, assumed mean is 50, and this is 20K minus 260 divided by 72 plus K. Now 20K minus 260 divided by 72 plus K is equal to 53 minus 50. So we have 20K minus 260 by 72 plus K is equal to 3, or 20K minus 260 is equal to 3 multiplied by 72 plus K. Here we have 20K minus 260 is equal to 6 and 216 plus 3K. Now 20K minus 3K is equal to 216 plus 260. 17K is equal to 476. K is equal to 476 divided by 17. Now 17 2 times and 8 times. So K comes out to be 28. That's the answer. Now the 14th question, in this we have to find the area of the segment which is shown in the figure, and we have a circle whose radius is 21 centimeter and angle AOB is equal to 120 degree. In this question we have to find the area of the segment, and we are given a figure in which the radius is 21 centimeter, and we have this angle as 120 degree. This is the chord AB, and we have a shaded region. Area of segment will be equal to area of sector minus area of triangle. This point is O. So triangle AOB. To find the area of the triangle, we need the base and the height measurement. So now suppose this is the triangle AOB, and this is 21 centimeter, this is 21 centimeter, and let OP be the perpendicular on it. And we know if we draw a perpendicular from the center on the chord, it bisects the chord. And we know this angle is 120 degree and it is an isosceles triangle. So we have this angle as 30 degree and this angle is also 30 degree. So 180 minus 120, angle sum property of triangles. In triangle OAP, sine 30 degree will be equal to OP by OA. So sine 30 degree is half. OP we have to find out. OA is 21. So OP is equal to 21 by 2 centimeter. Now let's find out AP. So in the same triangle, I can go for cos 30 degree is equal to AP by OA. So cos 30 degree is root 3 by 2. AP is to be found out and OA is 21. So AP is equal to 21 root 3 by 2. And we know AB is equal to twice of AP. So this will be equal to 2 into 21 root 3 by 2. 2 gets cancelled. So AB is 21 root 3. So this is the base of the triangle and this is the height. OP is the height of the triangle and AB is the base of the triangle. So we can use this as base and this as the height. Now let's come back to this formula now. Area of sector is theta by 360 multiplied by pi r square minus area of triangle. We can use as half into base into height. Now theta is 120 degree by 360 into 22 by 7 into 21 into 21 minus half, and base we got as 21 root 3 and height we got as 21 by 2. Now this 1 time and 3 times, 7 and 3 times, 3 gets cancelled. So we get 22 into 21 minus 21 root 3 into 21 divided by 4. Now let's take the LCM. So 22 into 21 multiplied by 4 minus 21, and this I can multiply by 1.732 multiplied by 21 divided by 4. Now I think I can take 4 common and 21 common. So I'll be left with 22 and minus 21 is gone, and now I'll divide 1.732 by 4. So 21 multiplied by 4 times 16 and 3 divided by 4. 4 will get cancelled. So I get 21 and this is 22 minus, now 21 multiplied by 433. Let's do a little bit of rough work. 21 multiplied by 433, and so we'll get 433 and 2 3 times 6, 2 3 times 6, 2 4 8. So I get 390 and 9 and 3 decimal points. So we get 9.093 equal to 21 multiplied by 12.907. 12.907 by 21. So we get 12907 and 2 7 times is 14, 2 9 18, 5 and 2. So we get 740, 1 and 7, 2 and 3 decimal points. We get this as 271.047 and we have found the area, so centimeter square. And so the area of the segment is 271.047 centimeters square. Now question number 15, we are given a figure where angle ACB is equal to 90 degree and CD is perpendicular to AB, and we need to prove that CD square is equal to BD multiplied by AD. In this question we are given a right angled triangle ABC which is right angled at C, and we have CD perpendicular to AB. Now we need to prove CD square is equal to BD multiplied by AD. Triangle ABC is similar to triangle ACD, as angle A is equal to angle A common. Then we have angle ADC is equal to angle ACB, both are equal to 90 degree. So by AA property of similarity. Now triangle ABC is also similar to triangle CBD, as angle B is equal to angle P because that's the common angle here. Angle BDC is equal to angle ACB is equal to 90 degree. So therefore these two triangles are also similar by AA property of similarity. Let this be the first equation and let this be the second similarity. Now from first and second we can say that triangle ACD is similar to triangle CBD. Therefore we can write down the ratio of the sides. AC by CB is equal to AD by CD is equal to CD by BD, as AD by CD is equal to CD by BD. So we can say CD square is equal to AD multiplied by BD. Hence proved. So in this 15th question we have a choice, and the other question says if P and Q are the points on side CA and CB respectively of a triangle ABC which is right angled at C, we need to prove that AQ square plus BP square is equal to AB square plus PQ square. In this question we are given a right angled triangle ABC which is right angled at C, and P and Q are points on CA. P and Q, we have to prove AQ square plus BP square is equal to AB square plus PQ square. Let's join. So this would be AQ and this is BP. We need PQ also, so this is PQ. This is right angled here. So now we can say in triangle BPC, according to Pythagoras theorem, we have BP square is equal to PC square plus BC square. And in triangle AQC, we have AQ square is equal to AC square plus QC square. Now let this be equation 1 and let this be equation 2. Adding 1 and 2, we get BP square plus AQ square is equal to BC square plus BC square plus AC square plus QC square. Therefore, AQ square plus BP square is equal to, now for PC square and QC square, I can write down as PQ square. PC square plus QC square is equal to PQ square, and AC and BC square I can write down as AB square. Hence proved. Question number 16. In this we are given a figure and in which a circle is inscribed in a triangle ABC having sides BC is equal to 8 cm, AB is equal to 10 cm and AC is equal to 12 cm, and we need to find the lengths of BL, CM and AN. In this question we are given a triangle ABC and a circle is inscribed. BC is given as 8 cm, AB is given as 10 cm and AC is given as 12 cm. And these points are L, M and N. And we have to find BL, CM and AN. Now here tangents from a same point outside the circle are equal. So let LC equal to x centimeter. So this is x. So therefore MC will also be x centimeter. This is also x. Then AM will be equal to 12 minus x centimeter. 12 minus x. Then AN will also be equal to 12 minus x centimeter. 12 minus x centimeter. Then NB or BN will be equal to 10 minus 12 minus x centimeter. So this would be equal to 10 minus 12 plus x. This would be equal to x minus 2 centimeter. Okay, then BL is equal to 8 minus x centimeter and BL should also be equal to x minus 2 centimeter. So this is the first and second. Now putting 1 and 2 together, we get x minus 2 is equal to 8 minus x. Now x plus x is equal to 8 plus 2. 2x is equal to 10. So x is equal to 5 centimeter. Now we have to find the lengths of BL. So BL is equal to 8 minus 5. So this is equal to 3 centimeter. CM is equal to x. So this is also equal to 5 centimeter. Then we have to find AN. AN is equal to 12 minus x centimeter. So this is equal to 12 minus 5. So this is equal to 7 centimeter. So answer we can write down as BL is equal to 3 centimeter, CM is equal to 5 centimeter and AN is equal to 7 centimeter. The 17th question says, water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 centimeter standing water is needed? This question, we have a canal may look like this, like a cuboid. Width is equal to 6 meter and depth or height we can say is 1.5 meter, and it is flowing with speed is equal to 10 kilometer per hour. And we have to find the area it will irrigate in 30 minutes. So time is equal to 30 minutes. And if 8 centimeter standing water is needed, volume of canal in 30 minutes is equal to volume of area with 8 centimeter water. Volume of canal I can denote by L into B into H, and this is equal to volume of area in the field, right? So length into breadth into height. Here we have distance is equal to speed into time. Here I can find out the length of the canal. Now length of the canal, so speed into time, speed is 10 kilometer per hour, so 10 I'll convert into meters, so 10 into 1000 divided by into minutes, so 60 minutes, and I have to find for 30 minutes, so I'll multiply by 30. So this gives me the length of the canal. Then breadth or width is given as 6 meter and height is 1.5 meter. And on this side, length into breadth will be area, which we have to find out, and height is given as 8 centimeter. So convert into meters will give me divided by 100. So now everything is in meter and minutes. So let's solve this equation now. So this is 1 and 2, 1 and 5. Now A is equal to 5000 into 15 into 6 is 90, 1 decimal point, so 9, and we'll bring 100 this side and also 8. Now this is 4 2 times and this is 25 times, and this is 2500. We get this as 62500 multiplied by 9. This is equal to 18 and 422, 256 meter square. So answer we can write down as it will irrigate the area of 562,500 meter square. 18th question, we need to prove that root 2 is an irrational number. To prove that root 2 is irrational, we are going to use the contradiction method here. So we can say let root 2 be a rational number which can be expressed in the form P by Q, where P and Q are co-prime integers. And Q is not equal to 0. Therefore, we can write down root 2 is equal to P by Q. Now squaring on both sides. We get 2 is equal to P square by Q square. P square is equal to 2Q square. Therefore, P square is divisible by 2. So we can say P is divisible by 2. Let P is equal to twice t. I'm taking 2t because I know p is divisible by 2. Now again squaring on both sides. We get p square is equal to 4t square. Now substituting p square is equal to 2q square. From the previous thing, we get 2q square is equal to 4t square, or I can say q square is equal to 2t square. Q square is divisible by 2. Therefore, q is divisible by 2. So let this be the first and this be the second statement. So from first and second, we know p and q both have a common factor 2. Therefore, p and q are not co-prime, and this contradicts our assumption. Therefore, root 2 is irrational. Hence proved. 19th question. In this we have to find the value of k such that the polynomial x square minus k plus 6x plus 2 multiplied by 2k minus 1 has sum of its zeros equal to half of their product. In this question we are given a equation x square minus k plus 6x plus 2k minus 1, and we are given that sum of its zeros is equal to half of the product of zeros, and we have to find the value of k. Now here in this equation we know a is equal to 1, b is equal to minus k plus 6, and c is equal to 2 into 2k minus 1. Now sum of zeros is equal to minus b by a, and that is equal to half of product of zeros is c by a. So we'll substitute the values now. So minus b I can substitute as minus k plus 6. So minus minus becomes plus, and k plus 6. A is 1 is equal to half, and c is 2k minus 1, and a is 1. So we can cancel these and we get k plus 6 is equal to 2k minus 1. 2k minus k is equal to 6 plus 1. So k is equal to 7. Answer. 20th question. In this we have to find the point on y-axis which is equidistant from the points 5, minus 2 and minus 3, 2. In this question we have to find a point on y-axis which is equidistant from, let's say this point A, 5 and minus 2, and the second point, let it be B, minus 3 and 2. Let the point on y-axis be, it is on y-axis, so x coordinate will be 0 and y. Let this point be P. We are given that this point is equidistant from A and B, so we can say AP is equal to BP. We are going to use the distance formula. So distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. AP will be 0 minus 5 whole square plus y plus 2 whole square, and BP is square root of 0 plus 3 whole square plus y minus 2 whole square. Squaring on both sides, we get 0 minus 5 whole square plus y plus 2 whole square is equal to 3 square plus y minus 2 whole square. Now this is minus 5 square, so 25 plus y square plus 4y plus 4 is equal to 9 plus y square minus 4y plus 4. Y square gets cancelled, and we have 4y plus 29 is equal to minus 4y plus 13. So 4y plus 4y is equal to 13 minus 29. 8y is equal to minus 16. So y is equal to minus 16 by 8. So we get as minus 2. So y is equal to minus 2. So answer the point on y-axis is 0, minus 2. We have a choice in the 20th question. So other question says the line segment joining the points A, 2, 1 and B, 5 minus 8 is trisected at points P and Q such that P is nearer to A. If P lies on the line given by 2x minus y plus k is equal to 0, we need to find out the value of k. In this question, we have 2 points A and B, and there is a line segment joining them. The coordinates for A are 2 and 1, and coordinates for B are 5 and minus 8. And this is trisected at points P and Q. So AP, PQ and QB are equal, trisected, and P is nearer to A. So now the ratio of AP is to PB will be 1:2. Now here we need to find out the coordinates for P, and we are going to use the section formula. Section formula, coordinates of the point which divides the line is equal to m1 x2 plus m2 x1 divided by m1 plus m2, and the y coordinate will be m1 y2 plus m2 y1 divided by m1 plus m2. Now let's substitute the values. So we have xy as m1 is 1 and x2 is 5, so 1 into 5 plus m2 is 2 and x1 is 2 divided by 1 plus 2, and the y coordinate will be 1 and y2 is minus 8 plus m2 is 2 and y1 is 1 divided by 1 plus 2. xy is equal to 5 plus 4 by 3, and this becomes minus 8 plus 2 by 3. xy is equal to 9 by 3 and minus 6 by 3. This gets cancelled by 3 and this is minus 2. So xy coordinates are 3 and minus 2. Now we have to find the value of k if the point P lies on the line whose equation is 2x minus y plus k is equal to 0. Now we know x is 3 and y is minus 2 plus k is equal to 0. So we have 6 plus 2 plus k is equal to 0. So k is equal to minus 8. Answer. 21st question. In this, a father's age is 3 times the sum of the ages of his 2 children. After 5 years, his age will be 2 times the sum of their ages. And we need to find the present age of the father. Here we are given that a father's age is 3 times the sum of ages of his 2 children. 3 times child 1 plus child 2. After 5 years, so father will grow by 5 years and his age will be 2 times the sum of their ages. 2 times the age after 5 years. Both children will also grow 5 years. So C1 plus 5 and child 2 plus 5. Father after 5 years will be 2 times C1 plus C2 plus 10 years. So this is the information we are given. Now we have to find the age of father. So let father's age be X. And we are given that the sum of children age is equal to 1/3 of father's age. Now after 5 years, father will be X plus 5 and he is equal to twice the age of children. Then so twice, and the previous age was 1/3x and 5 years are added to both, so plus 10 I can write down. Now we have got an equation. Let's solve it. So x plus 5 is equal to 2 into x plus 30 by 3. So thrice x plus 5 is equal to twice x plus 30. Now 3x plus 15 is equal to 2x plus 60. Now 3x minus 2x is equal to 60 minus 15. So x is equal to 45. Answer: the present age of father is 45 years. There is a OR question in 21st which says a fraction becomes 1/3 when 2 is subtracted from the numerator and it becomes half when 1 is subtracted from the denominator. We need to find the fraction. Let the fraction be x by y. If 2 is subtracted from the numerator, so x minus 2 by y, it becomes 1 by 3. Cross multiplying will get 3 into x minus 2 is equal to y, 3x minus 6 is equal to y, or 3x minus y is equal to 6. This is the first equation. Now secondly, they say it becomes half if 1 is subtracted from the denominator, so x by y minus 1. Now cross multiplying, 2x is equal to y minus 1, 2x minus y is equal to minus 1. This is the second equation. Now equating 1 and 2, 3x minus y is equal to 6 and 2x minus y is equal to minus 1. Minus, this becomes plus, and this gets cancelled. X is equal to 7. Now substituting the value of x in second equation, we get 2x minus y is equal to minus 1. 2 into 7 minus y is equal to minus 1. So 14 minus y is equal to minus 1. Y is equal to 14 plus 1. So y is equal to 15. We got x as 7 and y is 15. So answer, the fraction is 7 by 15. In this we have to prove that sine theta plus cosec theta whole square plus cos theta plus sec theta whole square is equal to 7 plus tan square theta plus cot square theta. In this question, we need to prove that sin theta plus cosec theta whole square plus cos theta plus sec theta whole square is equal to 7 plus tan square theta plus cot square theta. Now let's start solving the left hand side. So here I can open the bracket using a plus b whole square identity. So we have sin square theta plus cosec square theta plus twice sin theta cosec theta cos square theta plus sec square theta plus twice cos theta sec theta. Now this is sin square theta and cos square theta will become 1. This cosec square theta I can write down as 1 plus cot square theta plus 2 sin theta, and cosec theta I can write down as 1 by sin theta plus sec square theta I can write down as 1 plus tan square theta plus 2 into cos theta, and sec theta is 1 by cos theta. The sin theta gets cancelled, cos theta gets cancelled. We get 2, 4, 6 and 7 plus cot square theta plus tan square theta. This is equal to right hand side, so hence proved. There is a choice in this 22nd question too, and the other question we have to prove that 1 plus cot a minus cosec a multiplied by 1 plus tan a plus sec a is equal to 2. In this question we have to prove 1 plus cot a minus cosec a multiplied by 1 plus tan a plus sec a is equal to 2. Now solving the left hand side, first we'll multiply the second trinomial by 1. So we have 1 plus tan a plus sec a. Now cot a with all the three terms. So plus cot a plus cot a tan a. This will become 1, and plus cot a sec a. Now all the terms with cosec a, so minus cosec a minus cosec a tan a minus cosec a sec a. In this step, let's convert everything into sine and cos. So 1 plus tan is sine a by cos a, sec a is 1 by cos a plus cos a by sin a, and cot a into tan a becomes 1, so plus 1 plus cot is cos a by sin a multiplied by sec a, so sec is 1 by cos, so multiplied by cos a. Then cosec is 1 by sin a minus cosec a is 1 by sin a multiplied by tan a, so sin a by cos a, minus cosec is 1 by sin a multiplied by 1 by cos a. So here cos a gets cancelled and sin a gets cancelled. Now we have 1 plus sin a by cos a plus 1 by cos a plus cos a by sin a plus 1 by sin a minus 1 by sin a minus 1 by cos a minus 1 by sin a cos a. Now plus 1 by cos a minus 1 by cos a gets cancelled, and plus 1 by sin a minus 1 by sin a gets cancelled. We are left with 1 plus sin a by cos a plus cos a by sine A plus 1 and minus 1 by sine A cos A. So we get LCM as cos A sine A, and here we have 2 cos A sine A. This and this will be added, plus sine square A plus cos square A minus 1. I can write down this as 2 cos A sine A, and sine square A plus cos square A can be written as 1, then minus 1 divided by cos A sine A. Plus 1 minus 1 gets cancelled, we get, and sine A cos A gets cancelled with this, so we get 2. So this is equal to the right hand side, hence proved. Now we have finished section C in this video, and section D we are going to do in the next video. So stay tuned and see you all.